This is lesson 2 for the February break mini unit. We need to talk about some operations with square roots or radicals. Okay, so one thing to know about a square root, if you think about inverse operations, if you have the operation of addition, subtraction is its inverse. It undoes it. If you have a multiplication operation, division is its inverse. If you have a number squared, the square root is the inverse. So they undo each other. So an important thing to realize is if I start with x and I square it, and then I proceed to square root it, what I will end up with is x. This is very much how addition and subtraction works. If I start with x and I add 5 to it, and then I subtract 5 from that, what I will end up with is x. Addition and subtraction undo each other. If I start with x and I multiply it by 3 and then divide it by 3, what I end up with again is x. So same idea. Exercise 1 says find the value of each of the following principal square roots. Write a reason for your answer in terms of a multiplication equation. So square root of 25. What you want to ask yourself is what number squared would give you 25? And that's the number that we're looking for. So the number that we can square to get 25 is 5. So we can rewrite this as square root of 5 squared, and the answer to that is just 5. So the square root of 25 is 5. And the reason for that is because 5 squared is 25. Square root of 9. 9 is 3 squared. And the square root of 3 squared is 3. Because the square and the square root undo each other. Square root of 100, I can rewrite 100 as 10 squared. The square root of 10 squared is 10. 0, this is a weird one. I'm going to rewrite this as the square root of 0 squared. 0 squared is 0. So the square root of 0 is 0. When you have division, you are allowed to split the square root up. So the square root of 1 is 1 squared. And then I've got the square root of 4 on the bottom. 4 is 2 squared. So my answer to this would be 1 over 2. And then square root of 64/9. Again, I'm going to break up my square root, take the square root of the top, square root of the bottom. 64 is 8 squared. And 9 is 3 squared. Square root of 8 squared is 8. Square root of 3 squared is 3. So the square root of 64/9 is 8/3. So the big idea I want you to take away from this is if I can rewrite a number like 25 as 5 squared and then square root it, my squared and my square root cancel, and I know what the square root of 25 is. The square root of 25 is 5. This one's not in your packet. Exercise 3. Given the function f of x equals 20 plus the square root of x plus 3, which of the following is the value of f of 46? So let's do this by hand, and then we'll do this with the calculator. So if I want to find f of 46, I'm going to go to my original function, and I'm going to replace x with 46. So this becomes 20 plus the square root of 49. Well, I can rewrite the square root of 49. 49 is 7 squared. So this becomes 20 plus the square root and the squared are inverses, so they cancel. And I end up just with 7. 20 plus 7 is 27. Just to review this in the calculator, if we want to know a value of a function, we can graph it. So I'm going to do 20 plus the square root of x plus 3. I'm going to graph that. Now, nothing showed up, but that's okay. I'm going to jump to my table. And I want to know f of 46. So I'm going to have to scroll way down. And there it is, 27. Okay. Just like we could take a square root of 1/4 and break it up into the square root of 1 over the square root of 4. With division, you can break apart your radical. The same thing can happen with multiplication, okay? But we're going to see how this would work. So the first thing we're going to do is figure out what the square root of 4 and the square root of 9 are, and then we'll multiply them together. 4 is 2 squared. 9 is 3 squared. The square root of 2 squared is just 2. The square root of 3 squared is 3. 2 times 3 is 6. So I think the square root of 4 times the square root of 9 might be 6. And we took our square root first and multiplied the result. But what if we do the opposite? What if I multiply first and then square root the result? Well, that gives us the same thing. 4 times 9 is 36. I can rewrite 36 as 6 squared. Square and square root cancel, and I end up with 6. So it looks like when we're multiplying, I can take my square roots first and then multiply the results, as I did in A, or I can multiply what's under the radical and then square root the result. Let's just try one more to make sure that this really works. So instead of square root of 4, I'm going to write it as square root of 2 squared times square root of 5 squared. Square root of 2 squared is 2. Square root of 5 squared is 5. And I end up with 10 as my answer. What if I do my multiplication first, though? 4 times 25 is 100. This becomes the square root of 10 squared, and that is just 10. So once again, I can see with C and D that it doesn't matter if I do the square roots first or the multiplication first. They are equivalent. So that's what this property right here states, the multiplication property of square roots. If you have a product under your square root, you can break that product apart. Or if you have 2 square roots of a product, you can put those square roots together. Why would we want to do this? Well, let's look at part A. Square root of 2. There is no number that I can square to get 2. Remember, 1 squared is 1 and 2 squared is 4. So I cannot rewrite the square root of 2 as a number squared. Same thing with square root of 8. 8 is not a perfect square. So I can't take the square root first. So I'm going to multiply them first. So this will become the square root of 2 times 8, which is the square root of 16. And now 16 is a perfect square. It's 4 squared. The squared and the square root cancel, and that becomes a 4. Let's look at part B. 12 is not a perfect square, so I can't square root it. 3 is not a perfect square, so I also cannot square root that. So instead, I'm going to multiply them together first. 12 times 3 is 36. And now I can rewrite 36 as 6 squared. The square root of 6 squared is just 6. So sometimes if you can't take the square root first, you may need to multiply them. Same thing in C. I can't take a square root of 20. I can't take a square root of 5, at least not nicely. So I'm going to take the square root of 20 times 5 and see if that works. 20 times 5 is 100, and thank goodness, 100 is a perfect square. It's 10 squared. So I can get rid of my square root and my square, and I get just plain old 10. Sometimes the answers work out nicely like this. Sometimes they don't. So let's look at one last case, okay? What if we're not multiplying, and what if it's not a perfect square that's under the radical? So here they say, write each of the following in simplest radical form. So we're still going to use the idea of multiplication, but we're only going to reduce what we can. So first thing I'm going to do is I'm going to take my radicand, that's the number under the radical, and I'm going to break it down. So I'm going to think of two things I can multiply to get 8. 2 and 4. I'm going to circle 2 because 2 is prime. I can't break it down anymore. 4, however, can be broken down into 2 and 2. So what I know is 8 can be rewritten as 2 times 2 times 2. So this means square root of 8 can be rewritten as 2 times 2 times 2. Remember that squares and square roots undo each other. So I'm going to take this and I'm going to rewrite it. I see 2 2's here. So I'm going to rewrite that as 2 squared times this 1 2 that's left over. Now I can break this apart. Square root of 2 squared times square root of 2. Square root of 2 squared, those go away, and I end up with just 2 times radical 2. And that is my answer. A way that you can check this in your calculator, you can type in square root of 8 and hit enter, and then type in 2 radical 2 and hit enter, and you should get the same decimal. Okay, let's look at the next one, square root of 45. So I'm going to break 45 down into 5 and 9. 5 is prime, 9 is not. 9 breaks into 3 times 3. And those are both prime. So I'm going to rewrite square root of 45 as square root. I know I'm looking for squares, so I'm going to write it as 3 squared times 5. Interestingly enough, in my calculator, if I were to type in 3 squared times 5, I get 45. So we didn't change the value of the radicand. We just made it look different. Now I can break this apart because it's multiplication. Square root and square cancel. So I end up with 3 radical 5. Okay, let's do some more together. 48. 48 breaks into 6 times 8. You might use a different set of factors, and that's fine. Keep breaking it down. 6 breaks down into 2 and 3. 8 breaks down into 4 and 2. And 4 breaks down into 2 and 2. So I know if I do 2 times 3 times 2 times 2 times 2, I will get 48. To break down my square root, I want to find perfect squares. So that means I want to find 2 things I can multiply by themselves. So I've got a pair of 2's here. So I'm going to put 2 squared here. Down here, I see another pair of 2s. So I'll put 2 squared here. And then what's left in my factor tree is just a 3. Square root of 2 squared is just 2 times. Square root of 2 squared is 2 times radical 3. 2 times 2 is 4. So my answer is 4 radical 3. Okay, let's do a couple more. Now there's a negative out in front of my square root. So I know my answer is going to be negative times some square roots. 75 breaks down into 3 and 25. And 25 breaks down into 5 and 5. So I can see I've got a pair of 5s. So I'm going to rewrite that as square root of 5 squared. And then there's still this 3 left over. Now I've taken care of all of my factors. Square root of 5 squared is just 5. So this is negative 5 square root of 3. Next one, 72. This is a good one. If you want to pause this and try it, please feel free. 72 breaks into 9 and 8. 9 breaks into 3 and 3. 8 breaks into 4 and 2. 4 breaks into 2 and 2. So I'm going to see if I've got some pairs. I do. I've got 2 3s, so that's a 3 squared. Then I've got 2 2s, so that's a 2 squared. And then there's still this one last 2 hanging out, so I'm going to leave it radical 2. Square root of 3 squared is 3. Square root of 2 squared is 2. And then I've got this radical 2 that I cannot simplify. 3 times 2 is 6. So this simplifies into 6 radical 2. One last one. Negative square root of 500. So I know I've got a negative 1 times, and then I'm going to find my sets of squares. So 500 breaks down into 5 times 100, but 100 can break down more. 100 can break down into 2 and 50. 50 can break down into 2 and 25. Oop, I'm not going to circle 25. That breaks down again into 5 and 5. So now I want to look at my prime factors. I see a pair of 5s. So 500 has a 5 squared factor. I see a pair of 2s. And then there's this 1 5 left over. So this becomes negative 1 times 5 times 2 times square root of 5 stays because I can't simplify that. Negative 1 times 5 times 2 is negative 10 radical 5. Okay, that's the end of lesson 2. There's a Delta Math assignment called February Break Lesson 2. That's the next thing I'd like you to go ahead and complete.